Now, good morning, friends. We are discussing stability of the bodies. Maybe it is the body submerged inside the fluid, or it is floating on the surface of the fluid. So, stability of the submerged body. So, here we are considering the example of a balloon. So, the balloon is completely submerged in the air. So, this is the case of a body submerged inside the fluid. So now here the position of CG, that is center of gravity, and the position of B, center of buoyancy. So that will be get fixed in the completely submerged body. Now we are considering three states: stable equilibrium, unstable, and neutral equilibrium. Now stable equilibrium. So consider a balloon here which is completely submerged in the air, right? So let the lower portion of the balloon is having heavy material. So the mouth of the balloon is kept at the bottom. So the bulged portion of the balloon is exposed on the top. So we have heavy material here. So at the mouth, right? So now the weight of the balloon is W now, including the heavy material field acting through G, vertically downwards direction, whereas here buoyancy force is trying to, okay, the gravitational force is trying to make this balloon to go down, whereas the buoyancy force is acting upwards through point B. For the equilibrium, let us assume that the weight W acting downwards will be exactly equal to FB. So that is the buoyancy force. Now we are getting a small tilt here, displacement. The balloon is given an angular displacement in clockwise direction as shown in the figure. Now this G and W earlier were on the same line. Now they are separated by some distance now. So they are the two equal and opposite forces separated by some distance here. So this W acting vertically downwards, this FB acting vertically upwards. So these two are forming an a couple producing anti-clockwise rotation. So here the twist given here is a clockwise rotation, and this couple is producing anti-clockwise rotation. So this clockwise moment get cancelled with anti-clockwise moment. Because of these two forces, the body comes back to its original position. So this is stable equilibrium. So that is possible only when W is equal to FB and the point B is above G. The position of B is above G. Now the same balloons filled with the same weight of material, but now see here the mouth is on the top and the bulged portion is at the bottom. So here my B is below G. So here also we are giving a small tilt here, displacement in clockwise direction. So now G is having the force W, self weight, including the material field going downwards, and buoyancy force acting upwards. So weight W going downwards, buoyancy force acting upwards. So these two forming a clockwise moment. Here the tilt given is also clockwise. This couple of forces is also producing clockwise moment. So the balloon does not return to its original position. In the earlier case, clockwise moment balancing the anti-clockwise moment. Here, this is also clockwise rotation, and this couple also having clockwise rotation. So there will be still further tilting of the balloon. So case of unstable equilibrium. Then neutral equilibrium. So if W is equal to FB, that is both the weight of the body and the buoyancy force, they are equal and opposite to each other, and if B and G are lying on the same point, then the body will be in neutral equilibrium. So the case of balloon submerged in air, so that is completely submerged body case. Now stability of floating body. Earlier, the case of balloon and air. So, the balloon is completely submerged in the air. Now, floating body. So, the body is floating on the surface of the liquid here. So, the stability of floating body is determined based on the position of G and M. Here G and M will play the role. In the case of submerged body, so it is G and B which decides the equilibrium state. So stable equilibrium, if the point M is above G as we see here. So M is above G. So I am giving a small tilt here. G is the point through which the weight of the body is acts. So here the position of center of buoyancy from B, it is shifted to B dash. Buoyancy force is now passing through this point M. Now this is W going down, this is FB going up. So these two are forming a couple producing anti-clockwise moment. So this clockwise rotation getting balanced by this anti-clockwise moment. So thus bringing the floating body back to its original position. So stable equilibrium. So coming to unstable equilibrium now. So this is M below G. Earlier M above G, now M is below G. Here also we are giving the small tilt angular displacement here. So now B is shifted to its new position B dash. Now this W and this FB, they are two equal and opposite forces with some distance between them. They are not on the same line. So these two are producing clockwise moment. So the angular displacement given here is also clockwise. So clockwise moment get added to further clockwise moment. So still more the body get bent inside the liquid. The body will not come back to its original position. So this is unstable equilibrium when M is below G. So neutral equilibrium. If point M is exactly the center of gravity of the body, we say that the floating body is in the state of neutral equilibrium. Thank you.